From ContainerDays Hamburg, this video is proudly presented by DAX IT.
So as the title is quite lengthy, let's say it a bit shorter, what we are going to speak about. So we will tell about our journey to a continuum from cloud to edge. And with continuum, we mean here a seamless development, deployment, and operation experience between cloud and edge. So we want to bring the worlds together and have here a similar or same experience between both things. We tell this from a Stackit and Schwarz Group perspective, so the companies we're working in. Good. Before we dig into the details, let's do a quick introduction around who we are.
So, hi, I'm Martin. Currently, I'm working mainly on the Stackit distributed cloud. I have a strong background in industrial automation. Fun fact about me, I started using Kubernetes actually on bare metal. Then I went to the cloud, then back to edge. And nowadays, I am helping our customers to build clouds basically everywhere where they need it.
Okay, and my name is Timo Lackner. I'm head of Stackit runtimes and technical product manager. So my job is to develop managed runtimes in Stackit, not only in the cloud, but also on the edge. And just recently, we're also heading to distributed or private cloud. Okay, so let's set the context in which environment we are working in. So who is the Schwarz Group? What are we doing there? And what is Stackit? This is my first point. So the Schwarz Group is a group of different companies active in different divisions. I think most well known is the retailing division. Schwarz Group is one of the biggest retailer in the world. So we have Lidl there as the discounter and Kaufland as the full range article retailer. Then there is Schwarz Produktion, producing food like coffee, chocolate, ice cream, bakery, water, and what have you. Then we have another division for recovery and recycling. This is PreZero. So in many countries, they are responsible for the waste management. And last but not least, we also have our digital business unit, Schwarz Digits. So providing digital services and products. And Stackit, where Martin and I am from, belongs to Schwarz Digits. So what is Stackit? Stackit is the public cloud offering of the Schwarz Group. So it's available to the external market, but of course it's also the preferred cloud that we are using in the Schwarz Group. And a big focus of Stackit is on the topic of sovereignty. So it's a sovereign cloud for Europe. What do we mean by this? It's also kind of a buzzword, right? But we mean it serious. So we want to create an alternative European cloud offering to the hyperscalers. And we want to make sure that customers have always control over their data at all times. And more concretely, we see three important topics with sovereignty, which we also provide and offer with Stackit. So one is, so to say, legal and political sovereignty. So our data centers are all located on German and Austrian soil. So we are all in the legislation of Europe and Germany. So this is a strong protection against, let's say, foreign regulation changes, like US Cloud Data Act. Second pillar of sovereignty is our economic independence. So we are part of the Schwarz Group, big company. We are independent of investors. And let's say the risk to become candidate for a sudden acquisition is rather low. And third, we are also heading for technical sovereignty, technical independence. This is by focusing on open source and preventing technical vendor logins. So far to the product pitch. One more slide for the introduction, which should make clear about what scale we are talking about in the Schwarz Group. So here are some numbers they're quite new. So we have nearly 600,000 of employees in the Schwarz Group. We are operating over 14,000 stores with Lidl and Kaufland. Schwarz Group is active in 32 countries, and the revenue is 175 billion in the last business year. On the right-hand side, you see some of the production numbers of the food production. So 1.2 billion ice creams are produced per year, 48,000 tons of chocolate, and you can also read the other numbers. So it's quite impressive, and it should tell the Schwarz Group is really operating in big scale, right? And we also need a global scaling IT to support these businesses. Yeah. This holds true for the cloud, so for Stackit, but also for the edge computing use cases that we have. All right, so speaking about edge computing use cases, let's dig into the topic. So, of course, yeah, we have Stackit, we are using the cloud, but beyond cloud, we run local IT in every store, so in all those 14,000 locations, in every plant or factory, and in every warehouse. So we have plenty of edge locations and edge exposition here, so to say. So we brought some examples of real-life edge computing use cases from the different areas. And yeah, to get an understanding of what these are, let's dig into them a bit closer. So these are examples from the retailing sector, so from the stores, checkout, and logistics. So in the stores, we run one or multiple so-called store servers, which host applications for instance, these 4 examples. So electronic shelf labeling is one example. So these are the digital price shields, which replace the printed price labels. So this increases, for instance, the efficiency, yeah, and also yeah, allows us price dynamics, let's say. Then we have the topic digital signage. These are the monitors and the displays to interact with customers, showing advertisement or product information, and engaging more directly with customers. Another example, bottle return and coupons. I think you all know it. Yeah, the machines where you put your empty bottles, and you get the receipts, which you can redeem then at the checkouts. And we also have in-store analytics, like video, where customers are moving or how they move through the stores, where they rest longest, and so on. So these are examples from the stores. Then checkout. So you know the self-checkout areas. Here we have also AI video analytics use cases, for instance, product recognition, like fruit and vegetables. Or we have also age recognition, of course, anonymized, yeah. But to prevent, for instance, that we sell alcohol to minors. And we have the classical point of sales, yeah, which are also rather complex and big IT systems. They're not just doing the classical checkout of articles, but they are integrating with loyalty, with coupon, with inventory management, and the like. Okay, then logistics. So our warehouses, we have locally running the gate management, so managing the entrance for the trucks, which are coming for loading and offloading goods. Also appointment scheduling with the trucks, so to have a precise time schedule when they arrive. And also automated docking is one example of a use case, where we direct the trucks to the right gates, where they are unloaded and loaded. Okay, then some more examples from recycling, PreZero, and from production. So for waste separation, we have manufacturing lines or production lines with automated sorting systems, so robotics, scanners, video, and alike, to filter out products, or no, not products, materials, like batteries, which could, for instance, become a danger, could cause fires, and so on. Then we have the production. So here we have automated quality control with AI video analytics. So we control parameters like the color of bread, for instance, or the shape of bread to do automated quality control. And then all kind of industrial automation for the manufacturing lines, real-time monitoring of parameters, and predictive maintenance. So we have plenty of use cases, we have plenty of locations for edge. So it's an important topic for us. And question might be, okay, why can't we do this in the cloud? It's much simpler, right, to manage the life cycle of applications. And that's true. And maybe also some of the use cases can be shifted to the cloud, but definitely not all, because cloud sometimes is not enough. This is important to understand, and we listed here 4 important criteria. So the most important criteria for several use cases is the first one, operational continuity and autonomy. So this means that edge locations need also to function when network connection is down. So this is very important for the stores, yeah, for the checkout systems and for the stores in general. So I think no one has ever seen a Lidl store being closed because of a broken network connection. So this must not happen. This is not accepted. And similarly for production, if we depend here on central systems to manage the production lines and we have an outage in the network, this would mean we have an outage in production, and this would cost a lot of money. Yeah, so also not accepted. So another point is latency and data locality. Yeah, by processing data close to the source, this is important for real-time applications which do not want to have latency in between. The analytics, so the video analytics use cases are an example here, but also the checkout at the point of sales. Yeah. So if each article produces a small amount of latency, let's say 70, 80 milliseconds, this would sum up over 10,000 of articles and would reduce the throughput. And this is also not good, not accepted from our business. Network bandwidth is another criteria to go for edge. Yeah. So edge computing reduces the needed bandwidth and also the costs, which are produced by transmitting data. Especially important also, again, for the video use cases that we have here. And last but not least, improved security. So less data over the network means better security. I think this is clear. All right, so we need edge computing. And what's the status quo of edge computing in the Schwarz Group? So what was the situation when we started with our journey 1.5 years ago? So the Schwarz Group currently operates multiple custom edge computing platforms, which themselves are also highly automated and optimized for efficient operation. So we also have container runtimes running there already. We have VM environments running there. So let's say for each individual platform, situation looks good. But when we look across the platforms, we have a challenge. We have kind of disconnected edge islands. Yeah, for instance, we have fragmented deployment and operation processes across the platforms. And this means we have more effort that is required due to a lack of standardization and due to, let's say, a hindered cross-platform collaboration. So we are not using the full potential of synergies yet. And then another point, so the starting point of our journey, we lacked a cohesive cloud strategy that also included edge computing. And this was our starting point. So we came up with this shiny vision. So we said, okay, our goal is we want to consolidate, harmonize, and modernize the Schwarz Group's edge computing landscapes into a cloud-integrated solution that we can also offer as a generic product, as a generic runtime on Stackit. And second goal was we like to create an ecosystem for edge platform engineering so that we benefit from synergies and a higher speed of innovation. So these were two goals, big goals that we had. Then we sat together with all our internal stakeholders and discussed their most important requirements. And we came to 6 important goals, important capabilities that we want to realize with our product. So the first one is, we like to provide modern cloud-like environments in edge locations. Martin will speak more about this in a moment. And we like to provision those environments in a zero-touch provisioning manner, using a central cloud management plane. And we like to prevent that we need to send engineering staff to all those 14,000 or more edge locations. Another important factor for our stakeholders is that they can preserve the made hardware investments. So we have the store servers, as I mentioned, in all the stores. And if you calculate this, it's really a high price tag, high investment for all those store servers. So we like to support bring your own hardware. Then for this business continuity autonomy topic, so we cannot accept downtimes. Also in disconnected scenarios, we like to support autonomous operation of our edge environments. And as we're a big enterprise company, security and compliance is important. So we want to fit here to the standards and policies. And last point, on edge side, hardware capacity is limited. So we like to optimize also resource utilization on the edge side. All right, so product vision is defined. Product goals we have. So my job as a product manager is nearly done, right? Now let's implement it. How difficult can it be? Martin.
Yeah, thanks, Timo. Product management has spoken. Now we only have to build it. Not a big deal. So quite at the beginning, we settled on Kubernetes as our base layer. So basically, I mean, most of you probably don't have to explain this, but let's go quickly over it. Why Kubernetes is a nice choice for this. We want to have cloud-like environment. So what means this for us? We want to have, in general, a generic API to manage containers, and this should be independent of the location. So if it's in the cloud or on our edge locations, basically. Another big point is resilience. So I'll go deeper into this later. We want to have high available systems. They should have self-healing, all the nice stuff. And this is absolutely necessary for our critical autonomous edge environments. And last but not least, it has a great community, it has a huge ecosystem, so we can participate there, we can contribute there, but of course we can consume a lot of solutions for a lot of problems that others solved already. So this is why we like Kubernetes for this. What means this more concretely, especially in the cases that Timo explained? So we have a quite huge and diverse environment. So we have single node clusters, we have multi-node clusters, depends a bit on the location, depends on the dependency, on the requirements that we have there. And they have to be truly autonomous. So that means the control plane has to run on edge. In some regards, we even run Argo CD on edge, as an example. I know Git repository runs somewhere else. Still, we want to have as much as autonomous as we can basically get. To make it more concrete, we're producing a lot of food and other goods. And this means we have 24/7 operations. And this is a fun quote of one of my colleagues, which I really like because it makes it so easy to grasp what this really means. I mean, we're producing bread and other stuff, so at the end, the yeast and the ice cream is not waiting for us. We are producing this 24/7. So one feature of having, for example, zero downtime updates is like a huge win for us. And that was one of the drivers why back in the days they chose basically to use Kubernetes in this environment. But yeah, now we have Kubernetes, great. Now we have thousands of independent Kubernetes clusters spread over Europe. I mean, if you remember the numbers from the beginning, if you imagine you have Kubernetes in every store, we talk about, I don't know, 15,000 locations and more. So, and this has different hardware, from single board computers over standard server hardware to even small fog clouds. And at this point, everything is a scalability problem. I mean, you basically build a botnet. And yeah, I mean, if all at the same time try to pull an image, you can imagine what could happen there. So really great. So how did we solve it? I know Kubernetes is not an operating system. Don't pick on me for this one, but I think it makes it really, I like this quote simply because it describes what I want to accomplish with it. Like I said before, I have a deep background in industrial automation, so I'm working for, I don't know, 12, 13 years with different embedded Linux systems. And I'm personally really sick of scaling down a Debian system or Ubuntu, trying to make it somehow do what I need. I want to have something immutable, I want to have something deterministic, and as minimal as possible, because my goal is I want to run Kubernetes, and it should only do what is basically needed for this. So at that point, we then found Talos Linux. I think a lot of people know it here. Great product. Shout outs to Sidero Labs. Really nice what they're doing there. So we instrument Talos Linux for everything that we're doing here in this regard. Another thing is, so we have to manage now all this Talos Linux. Like I said, like thousands of clusters. So we need the management plane for this. We decided back in the days to build this on our own. So we built it based on Kubernetes, so KRM model, so Kubernetes resources at the end. And we use operators to manage the whole zoo in the background. So from the beginning, it was clear we don't only want to build this for our internal problems, because we see that other people have the same problem. So we will offer it soon on Stack It too as a product, so other people can use it. But now we have Kubernetes everywhere. Great. But Kubernetes is not selling bananas, right? So we need to put anything about like stuff on top of it. And to do this, we need even more. I mean, Kubernetes is simply not enough. So we have problems like application deployment, our policies, our observability. All this problem has to be solved. And we need a quite flexible platform for this. Like I said, different scales, different network connections. So a lot of interesting stuff happening there. And this has to work in an enterprise environment with all the nice things that we like corporate proxies. They don't go away. I don't know why, but yeah, that's a fact. What's our solution to this? It's a project called Kubara. What is this? It's basically a modular extensible toolset to customize a Kubernetes platform. So basically, everything on top of vanilla Kubernetes. This is based on the great work of our DevOps team, Schwarz Production. They built this back in the days. They're running this for several years. So together with them, we took it and generalized it now. And come to the next slide then, what we will do then with it. And this is working basically pure on a Kubernetes infrastructure and edge and cloud. So currently, this is inner source. I know, not so nice. But we strongly considering to open source it. So if you're interested and you want to collaborate, we're looking for partners there to work on it, because we think selling a bunch of Helm charts doesn't make really sense, but nevertheless, everyone needs it somehow, and it would be great to work together on this topic. So scan the QR code. The product manager is a product owner of it is here too. Annika, raise your hand. So you can go to her, or to me, or to Timo, and we're happy to talk about it. We really want to collaborate there. So what did we learn so far? Cluster is not a platform. So setting up a Kubernetes cluster is not a big deal nowadays. I mean, nice tools, no problem. But maintaining and running it at scale, secure, and so on, this is really like a challenge. I mean, this is really a lot of work, means a lot of processes. We were yesterday evening in the call of the HPA guys, the Hamburg Port Authority. They can tell stories about it. I mean, there's a lot that you have to do for this. Autonomy is key, at least for us. So we want to have our clusters completely autonomous, said this before. They have to work when the internet is down. In this case, like Timo said before, we can't close our stores because we don't have internet. It doesn't work. So, and they have to work for several days even without internet. Even you have to pay with cash, I know, but nevertheless, this is really important for us. We want to have it centralized, controlled, because managing a lot of these clusters is hard if you don't have one single point where you can manage them, and it has to be automated as much as possible, otherwise it's not fun at all either. Maybe a fun thing about operators. I know operators are great, we love them too. Building operators at scale is getting fun. I mean, if you have at some point thousands of objects, stuff is getting weird. Another colleague of ours, Tim, had a talk about how to scale operators. Yeah, great solution for this, for example. Our experience with it, everything was fine. If you have 2,000, 3,000 objects, suddenly we had 7,000, the whole shit went down. And then caching kicked in and really weird behavior I was not expecting. I mean, afterwards it made sense, but before that, well, I mean, we didn't expect this. So it's a hard challenge for sure. Our key takeaways, Timo.
Right. So first point is cloud sometimes is not enough. Cloud is good, yeah, but not the answer to everything. So edge computing is needed and is a critical growth area also for a lot of manufacturing and other areas like retailing, as we've seen. Our second wrap-up point is aligning cloud and edge creates synergies and a similar experience for the development process, deployment process, and operations. And we believe by this we bring the worlds together and bridge the gap. Yeah. Martin.
Yeah, building and deploying an edge platform is a journey, and I can't stress this more. I mean, we are not there yet. We don't have this rolled out everywhere. Why? Because we are basically working directly in the business value chain. So you need proper rollout strategies, how to really roll this out. You need maybe steps in between. You can't do a big bang in this scale. It won't work, at least for us, because if we interrupt the business there, well, you have to look for a new job probably, right? So this takes time, and you really have to plan this, and this means, at the end, sadly, years. And it's really frustrating, I mean, for me at least. And in general, we love Kubernetes. We truly believe it's ready for edge adoption. This one we have proven already, running it for several years. You can run Kubernetes on the edge. It's a great solution for orchestrating containers. Of course, it has an overhead, but it brings you so much more that you can profit out of it. So you can only encourage everybody, yeah, great, build your clusters at home in whatever locations. Kubernetes is great for this from our perspective. But you need efficient workload management at scale. It's clear too. Scaling Argo CD, different talk, different story, a lot of fun too.
All right, thanks for your attention. Time for Q&A round. Huh?
Thank you, Martin. Thank you, Timo.
Yeah, so first of all, control plane runs on edge in our case. So using the CNI, that makes sense at this location. We use a lot of Cilium in this case. On a single net cluster, yeah, Flannel maybe could be a solution, but we don't have the connection to the cloud. We have a channel back basically to reach our Kubernetes API, optional if this is needed. Has some other advantages, but we don't use the CNI for solving this.
Okay, thank you. How does the networking layer look like, and how do you connect to edge clusters, to central resources like registry?
Similar. Yeah.
Great question, too. You all know, I mean, the people who know PreZero know they have a tool called Omni, and this is similar what they're doing there. They, for example, use WireGuard, so build up VPNs, and this is not a solution for us. So in our case, and we know our customers who have similar issues, they don't want to have more VPNs. WireGuard, awesome technology, but in an enterprise environment, they don't want to have more VPNs, that more pinch holes in their network layer. So this is why ours is pure HTTPS connections. At the end, we use an operator scheme there too, how we manage it. Maybe in a different talk, we can go deeper into this. But yeah, we only have HTTP connections in this case.
Thank you. I see a lot of questions coming in. Let's see how many of them we can answer. What problems does Kubara solve that possibly alternatives don't?
Ooh, I can take
Please,
this.
Timo.
I mean, Kubara is, so to say, a toolkit to empower platform engineers to support a big number of application developers or application engineers with a consistent set of Kubernetes environments. So building up a Kubernetes platform with a high speed, so to say. Of course, there are also other alternatives, but as said, we had a good blueprint in place in our Schwarz Produktion. So I think somewhere here also the main inventor is sitting, Felix. And we saw that it really worked out in this real-life usage. I see also here the Lego colleagues. Hi. So you had something similar yesterday, right? You also had this problem. I think everyone has it. Kubara is now our answer to do this, and also to answer the next question, Kubara free to use. So we are heading to open source. So we set up now an inner source community to bring together all the edge platform teams that we have there, and this is working out already quite fine. And Annika is already working on setting up this framework also for open source. So if you're interested, contact us. We would be really happy to gain some more contributors or people interested to use it.
Thank you. Going to the next question. Schwarz has announced a partnership with GCP and Google, or Google GCP. How does this match with building up your own cloud?
Yeah, our CTO is giving us a thumbs up.
Difficult question.
You don't have to answer that if you don't want.
Well, at the end, we're using Google Workspace. I think this is a little bit mixed up. Yeah, Schwarz uses in the background GCP2 in some regards. We don't use AWS. You can guess why. This is a problem for us. And at the end, it's a transition. Yes, we push our own cloud. We try to move as much as possible to it. Maybe some services are missing. There are some other dependencies. This is why still it's a journey for us. Our goal, of course, is to use as much as possible our own cloud for most of solutions. But I think the partnership was with Google Workspace. I don't like this topic so much either. Truth is, there's no real full-fledged open source solution that works at that scale. We are 600,000 employees. It's complicated. And this is why they built something that the data is basically encrypted at the client, and to store the data and their exit scenarios, what possibly happen, how we get our data out, or this one's figured out. But yeah, we need probably other people to explain it more in deep, what is there. I hope it satisfies the question. Otherwise, come to us, and our CTO is here too. Maybe he can give a better answer there.
Yeah, I think you can meet Stackit people at the conference as well and talk about topics like that. How do you manage, or how did you manage the secrets in the edge?
Well, it depends heavily on the case, because we have a secret manager as part of Stackit. We use this one, obviously, for this, to store the secrets and in the cloud. Hope this one helps. Otherwise, shoot out with another question, yeah?
I think we have time for one and two questions. I would let you to choose which one do you want to answer. You see top 4 questions, they're top rated.
Kubernetes distribution is vanilla Kubernetes, basically what comes with Talos. The next one, rollers orchestrated. Yeah, complicated topic. We don't do blue-green there, for sure not. So it will be staging, QA, basically testing stuff. So it is today already. And then going in a slow rollout, for sure, but not really blue-green or rolling back. That's not the goal. It's more like at some point infrastructure problem that you can't update everything at the same time.
Okay, and do you want to answer the next one as well? How are rollouts orchestrated?
This we had.
Take your time to read it. So both sides, infrastructure, aka Kubernetes, and business applications, is there staging or blue-green?
That's what I said,
the
right?
stores that receive updates earlier?
So the
That's what I just answered.
Oh, that's
yes,
the one.
answered it.
Then
And the next one, are your cloud environments built on the same stack as the cloud and edge environments? No, yeah. It's not. For edge, we're using Talos as that, and in the cloud, we are using a different infrastructure layer here.
But the distributed cloud is based on the same technologies.
Okay, thank you. I think that's enough for the questions. Maybe you can find the Stackit people in the hall as well and have a discussion about it. It seems to be a big topic. Thank you.
All right. Thanks a lot. Enjoy the day. Bye-bye.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.